So in problems involving circles, when we're setting up our diagrams, it always makes more sense to call the center 0. I mean, if you want to call the top 0 as we do normally, that's fine too. But if you call the center 0, the calculations will be much easier. So this is the center of the circle. This is 0. Then the circle ends at -8. Well, the circle starts at -8 and ends at 8. And since this distance is 4, we should call the surface -12. Now we're going to pick a very thin strip on the circle. You can pick it from the upper half of the circle or lower half of the circle, it doesn't matter. We'll get the same answer. Let's call it that with delta x, as we always do, and we'll try to calculate the area of this strip. And it's located as xi star. Again, if you want to call the surface 0, then 4, 12, and 20, that's fine too. But the calculations will be harder. So what I'm suggesting is, in the problems involving circles, always call the center of circle 0. The computations will be easier. Okay? And as I said, if you want to pick the strip from the upper half of the circle, that's fine too. You can look at xi star here. I just picked it from the lower half. So we don't know the length of this strip, right? What we know is this distance is xi star. If this is k, this is also k. So then the area of the strip is actually 2k times delta x. And then we'll think about k a little. We'll try to express it in terms of x, xi star. But what about the pressure? The given units are in terms of meters, so we will have to use the gravity and the density. It will have to be rho, g, and depth, which is going to be, what is the density of water? It's 1,000 kilogram per meter cube. And the gravity is 9.8 meter per second squared. What about the depth of the strip? So this, what is this distance? What about this distance? 12, right? So it's going to be xi star plus 12. Does it make sense? Again, we're trying to find the distance from the strip to the surface. So this distance is the distance from the strip to the center of circle is xi star. And then from the center of circle to the surface, we have 12, so then it will have to be xi star plus 12.
What if you put xi star like under 0, it just doesn't matter?
No. Any questions so far? So this is, in terms of x, this is good to go. The only thing we got to figure out is what is k in terms of x. how can we find that? This is how can we find that. Let me draw the circle again. You know this is xi star. This is k, this is also k, and what is the radius of the circle? 8, right? And this has to be a right triangle, so we can set up Pythagorean theorem. Xi star plus xi star squared plus k squared should give us 8 squared. Does it make sense? I see some worried faces. Let me sketch it a little bigger. So this is what we call K, right? And we know that this is xi star. And what is this distance? That's a radius, so it has to be 8. It's given in the problem. So how would you set up a relationship between xi star and k? They're in the same right triangle, right? So obviously it will be, obviously we can apply Pythagorean theorem. Xi star squared plus k squared is 8 squared. Right? And then how would you solve it for k? 8 squared is 64, so k squared is going to be 64 minus xi star squared. Then k is going to be, since it has to be a positive magnitude, the square root of 64 minus xi star squared. So we were able to express k in terms of x, and the area can be updated as 2 times 64 minus xi star squared delta x. We got area in terms of xi star and pressure in terms of xi star. I think we're ready to set up the Riemann sum. So pressure times 1000 times 9.8 is 9800. Times the area, which is going to be 2 times the square root of 64 minus xi star squared delta x. We can pull the constants out. 9800 times 2, and the plate is from where to where? From -8 to +8. This will turn to x plus 12, and this will be the square root of 64 minus x squared dx. And as we stated in the beginning of problem, we just need to set up the integral. That's it.